Hi, my name is Willa Potosnak. I'm a senior biomedical engineering student at Duquesne University. I'm also a research intern at the Auton Lab, which is a part of Carnegie Mellon University's School of Computer Science. I will be talking about current research I'm working on titled Robust Rule Learning for Reliable and Interpretable Insight into Expertise Transfer Opportunities. Hospital intensive care is generally distributed to different intensive care units or ICUs. We hypothesize that clinical expertise can be shared between units to potentially improve outcomes for patients across ICUs. This expertise we refer to is in the form of machine learning models that predict risk of healthcare outcomes for patients. This hypothesis stems from the idea that patients with characteristics that more closely align with the majority distribution of another ICU may benefit from expertise or models derived from that ICU. Machine learning can be used to identify which patients would benefit from ICU expertise. However, machine learning interpretability is essential to promote clinician trust in the model-identified patients. The federated classifier selection algorithm generates decision lists with rules that identify patients whom external unit models would be more competent at predicting outcomes. Decision list generation is typically composed of two main tasks: rule generation and rule selection. Freckles uses a parametric rule selection approach, which can end up overfitting the training data with small sample sizes and result in excessively long decision lists that are uninterpretable and impractical. We propose an algorithmic rule pruning approach for use in building short decision lists and preventing the list from overfitting the training data. Rule pruning is performed using permutation testing prior to rule selection, with the objective of removing rules influenced by sampling variance and that would not generalize well when evaluated on new data. For permutation testing, we estimate the probability that rules are generated from a data set without permutated class labels, and prune rules that do not meet a defined probability threshold. We hypothesize that patients within ICUs with medical and surgical focus, or the MICU and SICU, may benefit from expertise derived from the alternate ICU. For this purpose, we conduct two experiments. Experiment 1 with SICU considered the local unit and MICU considered the external unit, and Experiment 2 with the local and external unit assignments switched. We then generate decision lists with and without rule pruning, and assess the decision list on whether the external unit model applied to rule-identified local unit patients improves the area under the receiver operating characteristic curve, or the ROC-AUC. We perform each experiment on two datasets, which we refer to as CH and MIMIC2. The results of rule pruning demonstrate that applying the external unit model to rule-identified local unit patients can improve classification performance on average over that obtained with application of solely the local unit model. Our results also demonstrate that decision lists generated with rule pruning are shorter on average and are thus more interpretable and practical. Our experiment number 2 with the MIMIC2 dataset demonstrates the value of rule pruning to obtain the same ROC-AUC as that without rule pruning applied, but while using less than 1/3 of the rules on average. Future work will focus on accurate and computationally efficient methods for determining the most appropriate probability threshold at which to prune rules. I would like to acknowledge support for this research under the following grants. I would also like to acknowledge collaborations with researchers at Carnegie Mellon University, as well as clinicians at the University of Pittsburgh Medical Center. Thank you to the following for their support and guidance throughout this research.